Hey folks, my name is Leo. I am one of the co-founders of Strange Science Instruments, and you are watching this presumably because you're interested in learning about how to set up this new product that we have just launched. This is the FC-16 format converter, and if you're not completely up to speed on what this is and who it's for, maybe pause this video and look at our overview video that covers that stuff in detail. In this video, I'm going to cover how to set it up, how to use it, and before we dive in, let me also mention that this is a short video. We have a user guide that covers all of this information and more in great detail. I wrote that user guide. There's no AI slop. There's no AI involved in the creation of that document. So have a look there. And between that guide and this video, hopefully you'll have a complete understanding of how to use this product. Okay, let's dive in. So here we have the product. Let's start from the back panel. On the back panel, you're going to find a USB-C connector, some dip switches, 4 optical inputs for ADAT, and an AES output on a DB25 connector. The USB-C is primarily used to power the unit. 99.9% of the time, you're just going to be sending power to this to power the unit. The system has extremely robust voltage regulation inside, so you can use any USB power supply you like. It doesn't have to be anything fancy. And we mean this. I've tested this on old USB power bricks and batteries and things from old cell phones and old laptops, and it all just works. Like, the unit only needs 2 watts of power to work and USB-C, and you're golden. You don't need anything special. The dip switches, there's 4 of them, and they let you set some special modes that I will cover in a separate video. The only thing to know here is that if you're not sure about what is going on, just set all these to the up position. If they're up, it means that's the default and that the unit should work as you would expect. Next, we have 4 optical inputs. Now, you might be wondering why we have 4 ADAT inputs when the system is 16 channels. FC-16 provides 16 channels of conversion, so why have 4 inputs? And the reason for that is because this box supports 96 kilohertz or SMUX modes. So there aren't a lot of people producing content, Atmos content in 96 kilohertz, but it is technically part of the spec, and we wanted this product to be compliant with that and to be future-proof. So if you are one of the people that either produces or monitors music in 96K, you can use this to convert your signals. In that case, use all 4 inputs and you're good to go. If you're working at 48 kilohertz, as most people do, myself included, if you produce Atmos content, it's probably coming out at 48 kilohertz, then you only need to use 1A and 2A. You can ignore the B inputs. The B inputs are only needed if you're working in 96K. So just connect your audio interface to 1A and 2A, and you should be good to go with your 16 channels of outputs. Speaking of outputs, we decided early on to make this product as small as possible, and the reason we did that is because we wanted to be able to place this anywhere. Like, we've got a mounting system that lets you mount the product to the bottom of a desk right near where you sit in your mix position. You can also put this in a rack if you like. I've got one here. And other places as well. You can wall mount it, you can put it in an equipment room, all kinds of stuff. And to do that, we needed to make the product physically small. And this helped us do that. So what you need is a breakout cable. And if you don't already have a breakout cable, the one that we recommend is this guy. This is a HOSA DTM-803 cable. It's got DB25 on one side and a whole bunch of XLR outputs that take your AES signals to each speaker in your room. So you got 8 XLR outputs for 16 channels worth of signals. And the marketing on HOSA's website doesn't mention anything about 110 ohm or AES EBU or anything like that, but we've tested this in our lab and the signals look great. Even over very long cable runs, everything looked fine, and so we have no problem recommending this because it's a good cable, it's well built, and it's reasonably priced. We actually like this cable so much that we became a HOSA reseller so that we can offer it along with the product on our website if you so choose, or buy it from your favorite retailer if you can get a better deal elsewhere. Now, you might already have a Tascam formatted cable. Let's say you already have one of these. This is a cable that I've had for 15, 20 years now from my old Pro Tools HD rig. It is a Tascam formatted cable, and this will also work just fine. It's got a DB25 on one side, and it's got a bunch of XLRs on the other to carry the AES out. The only thing you need to do with these cables is, you'll notice some of these are outputs, which is what we want, and then some of these are actually inputs, which is not what we want. This product does not have any AES inputs. So what we did was use these pins as outputs so that we can pack everything onto one cable, okay? Now, if you're gonna use a cable like this, all you have to do is buy one of these format converters. You can buy one of these on Amazon or through your favorite retailer for a couple of bucks. They're not very expensive, and they don't affect signal quality. So if you pop one of these on here, now you have an output. So you'll need 4 of those, and basically all of your connections turn into outputs that you can send off to your speakers. And finally, there's a third option for studio builders and system integrators. If you're comfortable with a soldering iron, you want to build your own cables, we actually have a pinout diagram available on our website that lets you know which pin connects to what. So you can do that using the diagram on our website. Let's take a look at the front here and go through that. First and foremost, we've got a knob. If you turn this down, it's 100 dB of attenuation. And if you turn it all the way up to the maximum position, then it's 100% of your signal passes through the unit unchanged. So in this mode, the bit perfect light comes on, which means that any ADAT signal that's coming in is being converted into AES and being sent out in a perfect fashion. Perfect as in, if you compare the output numerically to what you sent in, it will be exactly the same. The signals will null and you'll have a perfect conversion. This was important enough that we put a dedicated LED on there for more technical users. If you're a mastering engineer or you work in broadcast, you might need to know for sure that this is bit perfect, and that light lets you know that it is. To get this light to switch on, you need to turn the volume all the way up to 100% or use one of these dip switches to disable the volume control system completely. If you do that, then by definition, the signal that comes in gets translated and sent out exactly as it is. No changes, no scaling, no volume manipulation at all. Next to that, we have an active light that points to the volume control knob, and that is there because if it's green, it means the knob is active and you can change the volume. If you tap this, this is a clickable knob. So if you click it, you mute the output and this light turns yellow. When it's yellow, it means that the system is muted, but the knob is active. If you disable the volume control knob using one of the dip switches in the back, which I'll cover in more detail in another video, this light will be off. So that's that light. And over here, we've got 4 LEDs indicating the current sample rate. FC-16 locks onto whatever sampling rate that your audio interface is putting out. So if it's 48, you'll see the 48 light up. If it's 96, you'll see the 96 light up. Now, if you're producing content for Dolby Atmos, then it's going to be either 48 or 96. Those are the 2 officially supported specs of Dolby Atmos, but we decided to support all 4 just because we could, and there's no harm in having that. And finally, we have a lock icon which shows the lock status of the FC-16. This product has quite an advanced analog PLL circuit inside that can lock on to incoming signals and provide a super clean regenerated output that is sent out of the AES outputs. This is a custom technology that we developed in-house along with our FPGA core, and it's not available anywhere else. If you see this light in green, green is good. Green means that the system is receiving signals, it's regenerating the signals in a really clean way and sending them out in a precisely timed fashion to your speakers or whatever device that you've connected to this product. If you see it in yellow, That means that the system is unable to maintain lock and is falling back to what we call a pass-through state. Pass-through lets you keep working. It means that whatever signal is coming in is being sent right out to the output without the clock regeneration. So if there's jitter in the signal, then there will be jitter on the output. And this is not the desired output, but we've included that because it's better to have output than to not have output. So that's why it's there. And you can read more about this in the user guide. And so that is the product in a nutshell. As I mentioned, we've got some dip switches on the back, and I'm going to make a separate video to cover what all those do. So keep an eye out for that. If you haven't done so already, please click that subscribe button and the bell icon and all that to stay up to date on what we're doing. We've got some cool stuff in the works, so it'd be nice to have you along. And if you have any questions, leave them below or email us directly and we will get back to you with answers. Anyway, thanks so much for watching, and I will see you in the next one.